All right.
Hello. So today we're going to talk about the properties of logarithms. This is one thing that students seem to remember every year. So I'm sure it will be no different with you. Do you guys remember your properties of logarithms? What's a logarithm? Okay, so here are the three basic properties. Log base b of m plus log base b of n is equal to log base b of m times n. Log base b of m minus log base b of n is equal to log base b of m over n. Log base b of m to the nth power is equal to? What happens when you have a power? You can put it in the front. Every year students remember this one. So these are your three properties of logarithms, and we also have the change of base formula. Do you guys remember that? Like if you have a logarithm and you don't like working with base b, you can change it to any other base by using the log change of base formula. So log base c of a over log base c of b. This is it. That's the lesson. Okay, now you just gotta know how to use it. So a good problem to, like, I guess, I don't know, are we having another quiz? I mean, are we gonna have, of course we have a quiz tomorrow for period 1, but is the next one gonna be another quiz, or should we take another test?
Quiz.
Well, you don't get to decide. I'm gonna decide. I haven't decided yet. I'm gonna think about it a little more. Anyway, so the quiz that you're getting tomorrow is not covering this, or it's just expolog 1 and 2, so it should be pretty easy unless it's not. So, how about like this? If natural log 2 is equal to a, natural log 3 equals b, natural log 5 equals c, then write natural log of 4.4 repeating in terms of a, b, and c. This is the kind of typical problem from the textbook. Okay, so the first thing you gotta do is you gotta change 4.4 repeating into like a fraction. Come on, this is elementary school. 4, okay, what is 0.4 repeating? Okay, if we don't know that, you just can't do the problem. Wait, time out. When you come up from elementary school, don't you supposed to know your corresponding fractions and decimals? Like 0.5 is 1/2. 0.4 is 2/5. Oh my goodness, 0.375. What? 0.375, you don't know that's 3/8. So that's why we don't know 0.4 repeating is 4/9. Can you figure it out though, if you had to? Okay, let's go back to elementary school then. You guys never learned that point of 1/9 is equal to 0.1 repeating? Okay, wait, okay. Okay, what if you're in a Turkish prison and the only way the guard is gonna let you go is you gotta change 0.4 repeating to a fraction? Are you gonna stay in prison the rest of your life and just rot away? Or are you gonna be able to escape? Okay. Okay, this is how they taught you in Algebra 2. In fact, Mr. Rubash was just talking about it. Let x equal 0.4 repeating like this, dot, dot, dot. You guys remember what you did last year? Plus, I'm sure you did this in pre-algebra. Then multiply both sides by 10. Multiply both sides by 10. What happens when you multiply 0.44444 by 10? What do you get? 4.4444. Now is it starting to look familiar? Now what? Subtract. So what is 10x minus 1x? And what is 4.4444 repeating minus 0.4444 repeating? 4, therefore x equals 4/9. You guys never saw that before? Oh my lordy. You guys better, I hope you kept your receipt. You guys should go back and get your money back or something. Anyway, so that's how you change it to a fraction. If you can't do that, then Anyway, there's a pattern in this. Look, 1/9 is equal to 0.1 repeating. 2/9 is equal to 0.2 repeating. You see a pattern here? 3/9 is equal to 0.3 repeating. Let me ask you this. When was the first time you learned that 0.3 repeating is 1/3? And don't say yesterday. Really, when did you guys learn that 0.3 repeating was 1/3? Elementary school, right? But it's the same pattern, so 4/9 is equal to 0.4 repeating, and so forth and so forth. What is 8/9 then? 0.8 repeating. So tell me, what is 0.9 repeating then? It's 1, that's right. 0.9 repeating is equal to 1. Or is that going to blow your mind? Does everybody understand that 0.9 repeating, it's not approximately 1, it is 1? Or do I have to explain it? Okay, I'll explain it. Well, it's equal to 9/9. That's 1. Oh my goodness. All right, so we know now 0.4 repeating is 4/9, so 4 and 4/9. What is 4 and 4/9? Change that to an improper fraction. 40/9. All right, so now we can change this using your properties of logarithm. So using your properties of logarithm, isn't this equal to natural log 40 minus natural log 9 using this second one right here? Now all the logarithms we're going to do in this class, I'm going to do natural logarithms because that's what you're going to do in calculus next year. Okay, maybe once in a while I'll throw in some other ones. Okay? Okay, but now, Mr. Park, I don't even see a natural log 2, 3, or 5 here. This is 40 and 9. So what you're going to do is you're going to make it into 40 and 9. Change the 40 and 9 into like things, like for example, 9 can be changed to 3 squared. Now why would you do that? Because you can put the 2 in the front and that's how you get the natural log 3 there. Yeah, but Mr. Park, what about the 40? Well, isn't 40 the same thing as, well, tell me how you would break that up. 4 times 10, does that help?
Yeah.
8 times 5? I think 8 times 5 is better, yeah? 8 times 5, why is that better? Because that would be natural log 8 plus natural log 5, and then natural log 5 is c, right? Yeah, but what about the 8, Mr. Park? Well, isn't 8 the same thing as 2 cubed? And the reason why you want to write it as a power is because you can put the power in the front. So if I use that property, put the 3 in the front, you get 3 natural log 2 plus natural log 5 minus put the 2 in the front, 2 natural log 3. Final answer going to be 3a plus c minus 2b. Box that, that's the answer. This is to test to see if you know your properties of logarithms. And I guess it's also a test to see if you can change a decimal into a fraction. I didn't think we had to worry about that, but I guess we have to. Okay, now let's solve an equation. Okay, solve for x. Let me see if I can make one up here. Solve for x. Log base 8 of x, give me a number, x plus 2 minus log base 8 of x minus 1 minus log base 8 of x minus, give me a number, 3 is equal to negative 2/3. This is a typical Algebra 2 problem, but that's the kind you're going to get on the next quiz. I'll kick it up a notch if you take a test. Okay, so what you want to do is use your properties of logarithms to write the left side as a single logarithm. Is that possible? Because look, they're all log base 8. Yeah, okay, how do I combine these three logarithms into just one logarithm? Using, well, I erased it already, but using the first two properties of logarithms. Isn't this the same thing as log base 8 of x plus 2 over x minus 1, x minus 3? Isn't that the same thing? Because look, when you have this minus this, it's like this over that, right? And then when you minus that, it's like dividing again. So that's why you get the x minus 3 in the bottom. Come on. And then of course, once you get here, what do? How do I get rid of this log base 8? You can change it to exponential form, so you can go 8 to the this power equals this, or what did I tell you last week? How do you get rid of a log base 8? You ate it. You ate both sides, because 8 to the log base 8 of gorilla is gorilla. I'm going to multiply that out already. And 8 to the negative 2/3 is? Come on, that's algebra 1.
2, 4, 1/4.
1/4. Whoa, that took us a while to get that. Okay, and then now you got an algebra 1 equation. See, so what you got to do is you got to use your properties of logarithms to get it to that point, because once you get to this point, I think you can do it, right? Although on the test we had problems with the algebra 1 problem, yeah? The one, the repeated fraction. The one, 1 over 2 plus 3 plus 1 over 2 with that thing. We had problems with that one. Anyway, how do you solve an equation like this? It rhymes with cross multiply. Cross multiply. So x squared minus 4x plus 3 is equal to 4x plus 8. And it's a quadratic equation, so make one side 0. X squared minus 8x minus 5 equals 0. Is that factorable? No, so we're going to use quadratic formula. Now, are you guys good at just completing the square in your head? Like I taught you? Or are you just going to use quadratic formula? I don't care what you do, just get it right. X equals, see look, if you guys listen to what I teach you, man, it's watch. This is what I do in my head. Okay? What do I have to add there to make a perfect square? Take half of that and square it. 16. So if you add 16 to both sides, then x is going to be 4 plus or minus root 21. Because look, this is like x minus 4 squared equals 21. If you square root both sides, you get, well, let's see if you guys remember what happened 2 weeks ago. What is the square root of x minus 4 squared? And you better not say x minus 4, or plus or minus x minus 4.
Absolute value.
Absolute value of x minus 4. That's what it is. And what's the square root of 21? 20 square root of 21. And then, of course, if the absolute value of something is equal to this, then doesn't that mean this is equal to plus or minus root 21? I keep telling you guys, the plus or minus comes from the absolute value. So x is equal to 4 plus or minus 21. But if you keep on doing this over and over and over, pretty soon you can just do it in your head. Especially when this number is even. It's easy to do. Mr. Parker, just going to use quadratic formula. Okay, I don't care. You use quadratic formula, you should get that. But then again, on the test, a lot of people are, oh, we had problems with the quadratic formula. So box this, that's the answer.
No.
How do you know? Come on, what did your teacher teach you last year? Didn't we have to check our answers? How come? In fact, this is going to be on tomorrow's quiz, you know. When you have a logarithm, isn't there a domain? Right? Because there's no such thing as log of 0 or log of a negative number. So whenever you have a logarithm, this thing has to be positive. This thing has to be positive. That got to be positive. That got to be positive. There's no such thing as log of 0. 8 to the what power equals 0? No can. 8 to the what power will give you a negative number? No can. So, what is 4 plus root 21? Well, root 21 is about 4 point something, right? Because the square root of 16 is 4, right? So 4 plus root 21 is about 8 point something. So if x is 8 point something, is that 8 point something plus 2 positive? 8 point something minus 1 positive? 8 point something minus 3 positive? Yeah, so that one's good. But what about the minus one? What about 4 minus 4 point something? That's going to be negative point something. Is negative point something plus 2 a positive number? What about negative point something minus 1? Nah, right there. So we got to cross that one out. So your only answer is 4 plus root 21. So again, the easiest part of the problem, if you ask me, is using your properties of logarithms. Right? You guys remember those from last year, right? Students seem to remember that every year. Okay, what about the change of base formula? Are you guys good at that? Okay, let me see if I can think up a good one. Let me cook you up something good. Log base 2 of 3 times log base 3 of 4 times log base 4 of 5 times log base 5 of 6 times log base 6 of 7 times log base 7 of 8. Simplify this. Of course, if you have a calculator, you can just punch it in, because your calculator you can punch in any base logarithm, right? Except you're not going to have a calculator on this test. So what do? What happens when you see logarithms and all the bases are different? Change the base. Now, you can change it to any base you want. You can change everything to log base 2, or change everything to log base 8, or change everything to log base 3, it doesn't matter. Or change everything to common log, base 10, or change everything to natural log. What should you do? Since I told you that calculus is all natural logarithms. Yeah, you guys should get into the habit of just doing natural logarithm. So using the change of base formula, what is this? Natural log 3 over natural log 2. It's so simple. The top number goes on the top, the bottom number goes on the bottom. Right? Didn't your teacher say that last year? It's so easy. Next one. Natural log 4 over natural log 2, oh 3, sorry. Next one. Natural log 5 over natural log 4. Natural log 6 over natural log 5. Natural log 7 over natural log 6. Natural log 8 over natural log 7. How many points do I get for that? Well, if this was worth 5 points, I'll give you 1. Because at least you can regurgitate the change of base formula. But then now we can simplify this. These cancel, these cancel. So all you have left is natural log 8 over natural log 2. Okay, now you get 1 more point. But still, that's not simplified. So there's so many things you can do. What do you want to do? You want to change it. You want to change it to, isn't this the same thing as log base 2 of 8? The change of base formula going back, kind of backwards. And then 2 to the what power equals 8? 3. So that's another thing, that's one thing you can do. Another thing you could have done is, isn't 8 the same thing as 2 to the 3rd power? Yeah, why do you want to write it as a power? Because you can put the power in the front, and then the natural log 2's cancel out, and you get 3. So, I mean, no matter what you do, if you do correct mathematics, you're going to get 3. So that's a demonstration of the change of base formula. So, when do I use it, Mr. Park? Whenever you see logarithms with different bases, that's when you're going to use the change of the base formula. I think there's only 2 or 3 problems maybe on the homework that you, most of the problems on the homework, you got to use your properties of logarithms, the 3 properties. So I don't think, well, I don't know. The algebra part is the part that's going to get you. Right? That's what I think. All right, so that's it. And then we just got to practice doing harder and harder problems. You got to like recognize certain things, when you need to do what. All right. Short lesson, okay, but now going over the test might take a long time.